Hello, welcome to JavaScript Byte video series on Learn Awesome. If you have ever Googled how to reduce event spam in JavaScript, you have probably run into two terms, Debounce and Throttle. Learn Awesome has two detailed videos on Debounce for React and JavaScript, but the most common question I still get is, what's the difference between Debounce and Throttle? So today's video is all about that comparison, using one simple scroll example to show exactly how they behave differently and when to use which. So I'm going to dive straight into code to show you rather than keep talking about it. So let's jump into a fresh HTML file and build this from scratch. Right, this HTML file gives us a tall page to scroll, which will generate lots of scroll events, perfect for our demo. We have added two simple floating boxes. One will display when the user stops scrolling, and the other will count how many times the scroll handler actually runs. These will help us visualize how Debounce and Throttle handle rapid events differently and visually see the cost savings from Debounce and Throttle. Right, let's now talk about why do we even need Debounce and Throttle. So JavaScript events like scroll, resize, or even input can fire dozens or hundreds of times per second. If you run logic inside them, like fetching data using API from server or querying a database, it can kill performance and burn through cache fast. At minimum, it would make your page laggy as you are unnecessarily processing so many events without cause in most cases. That's where Debounce and Throttle come in. Both help you control how often a function or event handler runs, but they behave very differently. So let's first see how Throttle behaves. Let's break this down line by line for clarity. This throttle function takes another function fun and a time interval in milliseconds as arguments. It returns a new function that keeps track of when it last ran. Inside, we check the current time with date.now. If it's been long enough since the last run, we update last time and call the original function. Otherwise, we ignore the call. This way, even if the scroll event fires hundreds of times per second, we only run our logic every 100 milliseconds or so. Throttle ensures a function only runs once every fixed interval. Here we'll use it to update the scroll progress bar every 100 milliseconds, ignoring hundreds of spam events we receive in between. Debounce is different. It waits until the events stop firing and then runs a function once. Imagine detecting when a user finishes scrolling to the bottom of the page. You don't want to check constantly, just once they have stopped moving. So let me type the debounce function so we can compare. So let's dissect this line by line. Debounce take a function fun and a delay in milliseconds. It returns a new function. Every time that new function is triggered, for example on scroll, it first clears any previous timer with clear timeout. Then it starts a new timer using set timeout. Only if no events come in during that delay does it actually run fun. So if user keeps scrolling, the timer keeps resetting and nothing runs. But if they stop scrolling, wait 500 milliseconds, then the function runs once. The bounce waits until the event stops firing. It waits to check if the torrent of events is finally done, then runs this function once. We'll use this to detect when the user finishes scrolling. If you're unclear how the return function retains value of timeout ID, you are welcome to see the debounce video for vanilla JavaScript on our channel, where this is explained properly. Alright, let me now add the event handling code that would actually use these functions so we can visually see them on the page. So let me type first. First, the throttle function updates the progress bar based on scroll percentage every 100 milliseconds, and we are counting how many times it actually runs versus hundreds of events that never reach our function. Then the debounce function waits until you stop scrolling for 500 milliseconds and updates the message once, and we count that too. Lastly, we keep track of how many scroll events occurred in total so we can see the savings. Let's test this in the browser. So I'm going to save it. Watch the progress bar update smoothly while we scroll. That's throttle in action. Now stop scrolling and boom, the message at the bottom changes. That's the bounce. If we scroll all the way to the bottom and stop, it even tells us we reached the bottom. And take a look at the event count. You're seeing 63 throttle calls instead of 259. The bounce just twice. This is real savings. This prevents API overload, database spam, or even hitting rate limits on paid services. You are literally saving money and keeping your app fast. Let's break it down side by side for clarity. Throttle runs a function at regular intervals during activity, like a scroll progress bar that updates smoothly as you move. The bounce waits. It only runs after the activity has stopped, perfect for detecting when scrolling ends. Use Throttle for real-time updates or animations when you need steady feedback. Use Debounce when you care about the final result, like submitting a form or calling an API once. Throttle controls how often sometimes runs. Debounce controls when it finally runs. So now you know the real difference between Throttle and Debounce, and you saw them working side by side on the exact same scroll event. Let's go over some real life use cases for both Throttle and Debounce, starting with Throttle. Let's take example of a Windows resize listener. When someone resizes the window, layout calculations can be expensive. Throttle helps run updates at regular intervals instead of constantly. Next situation is real-time mouse tracking, for example in a drawing app. In such apps, you don't need every tiny movement. Throttle lets you track position smoothly without overwhelming the system. And lastly, live type metrics like word per minute counter. If you're showing typing speed live, you don't want to update the number every keystroke. Throttle keeps the counter steady and smooth. Let's go over some real life situations for Debounce as well, starting with search input with suggestions. As the user types, Debounce waits until they pause before fetching suggestions, saving bandwidth and avoiding API spam. Autosave form drafts. Instead of saving on every change, Debounce waits until the user stops typing. Then it saves the draft once without interruptions. And lastly, username availability check. When checking username availability, Debounce avoids hitting the server every keystroke. It waits for the user to finish. For a deeper dive into how Debounce works using closures and also how to implement a search input control with Debounce, check out the video I mentioned earlier. Its link is in the description. If this helped you finally understand the difference, leave a like, hit subscribe, and tell me in the comments what topic you want next. Thanks for watching. Goodbye.